Welcome to Headwaters Science Center again. Today we're going to do a virtual field trip. Attendance has been down, but we're not letting that stop us. We're not letting that not put our content out. Today we're going to talk about our Nano exhibit. And while some of it has been removed from the exhibit floor, we expect it all back soon, we're going to talk about what's here. This exhibit was created in 2015 and deeded to us in 2019. And it's an interactive way to explore nanotechnology, which everyone will tell you is the technology of the future. And what is nanotechnology? Well, nano means small. We all know that, but how small is that small? Well, technically, a nanometer is 1/billionth of a meter. Now, we throw billions around, billionths around a bit too, but that's really, really, really small. How small is that? Well, it's this small. Since I started talking about it, my fingernails have grown about 30 nanometers. So it's small. I can't see my fingernails grow, but they grow small. All right, well, let's look at one of the display boards that we have. In here, we talk about uses for nanotechnology, and it's for surface coverings to keep them from having bacteria and some other things land upon. And it's often used in circuitry. And people say, well, I don't have any connection to nano. Yes, you do. You do in nature. You actually have a nano sensor built right on the front of your face, your nose. And so particles of smell can be near nano size. So one of the things I wanted to feature here was this idea of the blue Morpho butterfly, one of the most amazing animals on the planet. It utilizes nano structures. I wouldn't call it technology, but nanobiology. So this animal doesn't know why it's so strikingly beautiful, but if you've ever seen them, when they flap in the sun, they glow and glisten and change colors. But as you look, can the folks see that, Ryan? It has a beautiful blue iridescence, and you can actually see two different colors on it, a brighter blue side and a less bright blue side. And you'd say, that's a beautiful blue butterfly. But the truth of the matter is, that's actually a brown butterfly. And the reason that it looks blue is because if we could get it to a larger scale, or to a bigger impression and scale up, we could see that there are channels in there. They're actually 200 nanometers wide. And what they do is you get light reflecting in those 200 nanometer channels. And so it's built with ridges and channels. And the reflective image from that to our eye is around 400 nanometers. It doubles actually coming back out of that. So what we see is this brilliant blue, which is in that 400 plus nanometer range. All right, that's really all I wanted to show over here. Ryan, why don't we pan the exhibit boards. This is the introduction to nanotechnology, and I'll meet you over here with a couple of the other exhibits. Ryan's moving through. It's just a way to explain where nano is in the world, where nano fits in our displays, and Your Honor, as we move into the idea of what is nano, let's think about the world in these sizes. We live in the macro world. In the macro world, we measure things in meters. I'm about 2 meters tall. And then, of course, you all know about the biological world. In the biological world, we often look at things in micros, in the micro world, and those things are very small. We can't access them directly with our eyes. So we use scopes, we use optics and lenses, and we spread that image to a larger image that our eyes can now comprehend. And when we get to that world, we see amazing things. We see things that our eye never experiences. But when we get to the nano world, we can't even access that with a straightforward microscope. We need to have electron microscopes, and they essentially image things out by shooting electrons around and seeing where they do and don't go. But the scope of nanotechnology in this exhibit is the idea that things act differently on the nanoscale. Well, here's one way that we do that, and a lot of this is a metaphor because these are definitely not nanoparticles, but they're made of the same material. And and we spin one with the bigger beads, we see it sort of falls down due to gravity. When we spin the other one, we see it falls down due to gravity, but also jumps around, attracts to other surfaces, and does some sort of interestingly different things. And that's because at this scale, while it's not the nano scale, we have attractions that are more powerful, static attractions, that are more powerful than gravity pulling it downward. So we see those sorts of movements that we could only access in the nano world with electron microscopes. All right, well, what good is this? It's fun to see. It's fun to use that metaphor and bring that to our realization. Let's look at this one. This is really an interesting piece of nanotechnology, and it again builds that smallest idea in here. And we've all had this experience where we mess around with particles of iron and magnets, and we can make them attract and show some things, some crude changes, spikes, and differences. And this is the small one. We're going to move around and get to the smaller one, because sometimes we want to see how things act in the smaller world. And we can see how those spikes, bring those up, are a little more well defined. And you can see their field lines expressing themselves. Those are flux fields. And they actually are showing us more interesting pieces. And this one is filled with ferrofluid. Can you get a shot of that, Ryan? And if you look at that, you'll see that there are clear spikes. Now in ferrofluid, there are nano-sized iron particles, and those nano-sized iron particles are easily showing those field lines where the gravitational field is, or the magnetic field, I should say, is stronger and moves more ferrofluid to its tip. Now, I really wanted to make the point of how small nano really is. And so I thought, well, how am I going to do that with something that makes sense? But let's just look at this ferrofluid for a second here, because I think it's absolutely captivating the way we can play around with it and make it move inside the mission to make. And in their notion was, how are we going to get fuel to our rocket engines to refire them in zero gravity? And they weren't certain how to do that. And so a couple of their scientists developed ferrofluid in order to move fuel with magnets. They also didn't want to have engines that sparked and things, so they thought this could work. You know that these are part of the new loudspeaker design. They're used around tweeters and woofers to keep them cool. And if you can keep your woofers and tweeters cool, you can put a hotter signal into them. And anybody who wants great sound wants a hot signal in their speaker setup. So some of the other places we've seen ferrofluid get used is to seal anything that goes around, that moves, like for instance a hard disk, to keep it sealed in, because it'll form a moving seal between the inside and the outside of something. But lately, ferrofluid has come back into focus again in medicine. And the newest way that medicine is sort of taking aim, if you will, to use a term that actually applies well, is with targeting drugs. And they're putting magnetic pieces and tiny ferrofluid particles in with the drugs themselves to directly target cancers. Well, you can kill a cancer pretty easily if you can penetrate its cell, get into it. And so they use these nanoparticles to get into the cancer cells and destroy them. And if you can destroy cancer cells, well, you can save the life of the host. There are other medicines where targeting drugs and cures can be real beneficial. If you have drug-resistant bacteria, for instance, you could target right to the spots, fungal infections, other things. So medicine holds nano promise. They've even used nano fluid to complete neural connections in brains. And so there's a lot of things that are heading towards the future of medicine, and it's all, a lot of it is small, a lot of it is going way small. Well, probably the 7th inning stretch of the coronavirus, what I hoping we don't go into extra innings. And one of those gee whiz size facts came up the other day, and there's also some pretty practical facts about how much, and some scientists worked this out, how much virus is actually circulating around in the air, infecting the world now. Well, this data comes from 3 weeks ago, and we aren't that much further from 3 weeks ago, but the total amount of viral elements could fit in a 12-ounce can. Well, how big is the coronavirus? And so I had to look at my notes here, and it hasn't been well measured, but the coronavirus is about 50 nanometers or 75 nanometers, depending on its, how big it is, or how big that particular portion of it is. Well, as you've been watching our shows lately, we've been wearing these masks. Now, I don't have the N95 on, I've got the N94. And what this is rated at, and keep track of my numbers here with me, is to hold back 95% of 300 nanometer particles. And I just told you that the coronavirus is actually smaller than the particle size in these masks. Well, the reason why they're still quite protective, and even masks that aren't as well driven or derived, is that they tend to travel in more than one particle, and they are also suspended within our spittle, which has sneeze droplets are in the micrometer size, so they're 5,000 nanometers. So they still are very protective.
So micro is 1,000?
1,000, right? It's 1,000. A billion. So we're still on the safe side of this world with these on. To keep in mind, I mean, the size of the DNA is, generally considered to be about 2 nanometers wide. Now we could throw numbers all day around this and that, and it just probably get you more and more further from realization. But I have to remind myself of things every day about how small things are, about how atoms and elements, I mean, we're talking about things the size of hydrogen atoms too here. So things that we can't access directly with our eyesight, we have to use our tools to do. And that's another one of our virtual field trip. Oh, we've got a question out there.
So the ferrofluid, is the ferrofluid a liquid, or is it like a solid suspended?
It's the small particles are iron, so they're going to be solid size pieces that are suspended within this fluid, and the fluid is about 3 or 4% iron nanoparticles inside of there are different formulas for this. I had once created a Nano Exhibit, but I didn't have the expensive fluid, and so the better the fluid, the better it holds it. But it's an inter-surfactant which keeps it sort of true to its field line nature. It's I don't know the formula of this one. Everybody who uses this stuff holds their particular formula to be secretive.
One of the models was broken when it got shipped to us. It got broken shipping, and we replaced it with mineral oil. I think it's the biggest one, maybe. It's just mineral oil that we put in.
Right. We did. Yeah, right. And then, so that. But the fluid itself also has a surfactant in there to make it so it plays true in there, and it lies on the bottom, and then it kind of. But you can see how we're really what we're looking at here are the field lines of the magnet here. This is a strong enough magnet, probably neodymium. I haven't taken them apart yet. Have you seen any of these apart yet, Brian? I haven't checked out their field strength either, but
I assume that the magnets are all the same on all of them.
Yeah, well, they're not all the same distance, if you noted. Some of them can get closer. Oh no, they are all the same distance. I was just using this one wrong. I got it. All right. Are there any more questions out there in the ethers field, if you will?
Let's go on for today.
Okay, well, come on, visit us. We have this exhibit out here. We have some other nano exhibits out here, and we expect in the next few months that we're going to get them all out here, some of the more interactive stuff. The idea is to get here and let your body play and your mind play along and try to figure out things, and maybe you'll come up with the next use for ferrofluid.